In the last video, we learned about the factory pattern, in which a function or object creates a variety of other objects. In the last video, we created a factory to make droppables, sprites that can drop from bricks and be caught by the paddle. The droppable factory just needs the type of droppable, and it produces a functioning sprite. The droppable factory has some big design advantages. The data that describes a droppable is separated from the process of creating a droppable and all the code in the game loop that handles drawing and collision detection with droppables. We can therefore create new droppable types and just add their data to the droppable factory dictionary to get whole new droppable sprites. Maybe you tried that when you did the homework. This powerful extensible pattern can be applied to power-ups. Power-ups have a little more to them than droppables because they have an effect on the game, like speeding up the ball or changing the size of the paddle or increasing the number of balls, paddles, or points for smashing a brick. But don't worry, by reusing the factory pattern, this is just going to be a remix of ideas you've already learned. Let's get started. Step 1 is going to be to create the power-up class. A power-up will have a temporary, timed effect on the game. I'm going to make power-up a subclass of sprite because then I can throw it in a group and send the clear, update, and draw messages to it. This lets me give it a visual element that indicates it's active, and being part of the update cycle means I can check when its time is up and kill the sprite. Let's start with a really simple power-up class that is a subclass of sprite, takes an image and center X, center Y coordinates as parameters to init, and sets the image and rect fields in the usual way in the initializer. We'll then add two fields for managing timing, self.startTime, which we will set to pygame.Time.getTicks. Think of that as the time the power-up was created. And self.duration, which we could set to 3000 milliseconds, or 3 seconds. In the update method, we'll check if the 3 seconds have elapsed with if pygame.Time.getTicks minus self.startTime is greater than or equal to self.duration, and if so, we'll send self.kill. We can hook this into our game by creating a power-up group and sending it the clear, update, and draw messages. To test it, we'll create one at the start of the game. We'll put it in the center of the scoreboard, and we'll just use an image I already have, the coin image. Right now, this power-up doesn't affect gameplay yet. We're building the structure first so we can test each piece independently. Let's run this. You can see the coin in the center of the scoreboard for 3 seconds, and then it disappears. On to step 2, connecting that to a droppable. The player should be able to catch a droppable and get a power-up in return. We can do this very generally using our factory pattern. Let's make a power-up factory class. It will be a lot like droppable factory. I'm going to copy-paste that and rename it to power-up factory. In the init method, we'll keep the image folder. We'll rename the dictionary to powerup.dict. In the dictionary, we'll start with one type of power-up. Let's call it point doubler, so that will be the key, a string. The value is our dictionary containing the callable and the parameters for the power-up. The callable will be power-up for now. We can imagine in the future that will be a specific subclass for each type of power-up we want to create. And the image is the coin right now. There's no sound. We can delete the getRandomDroppableType method because the power-ups will be linked to specific droppables. And let's change the drop method name to getPowerUp. This is where we want to create and return a power-up. It will take a parameter, powerup.str, which is the type of power-up to create. Changing the code is a matter of changing droppable to power-up in several places, and then we have only the 3 arguments to the callable, the image, center X, and center Y. In the game, we'll want to create the power-up factory object, and we'll take out the testing code that creates a power-up right at the start of the game. We'll just create an empty power-up group. Now, down where the droppable is caught by the paddle, we're playing a sound. Let's also generate a power-up. That's going to look a lot like the code where we generate droppables. We'll get the proper power-up from the power-up factory and add it to the power-up group. I'm going to write power-up equals powerupfactory.getPowerup. And the first argument is the type of the power-up. We're going to be getting that from the droppable, but as an intermediate step, let's just pass in point doubler, the only power-up we've created so far. And then scoreboard.rect.centerX and scoreboard.rect.centery for its location. Then we'll add that to the power-up group with if power-up is not none, powerupgroup.addPowerup. Let's test that before we add a power-up component to each droppable. And when we catch a droppable, we get the coin in the center of the scoreboard for 3 seconds. Excellent. Now the missing piece is passing in the powerup type from the droppable rather than our hard-coded point doubler. I'm going to write droppable.getPowerup. That will be a method in droppable that returns the type of powerup. We'll need to add that to our droppable class, subclasses, and the droppable factory dictionary. Let's start with the droppable factory dictionary. For each entry in the dictionary, I'll add a new key, powerup, and for now they'll all be either point doubler or none. In the future, of course, we'll want each droppable to generate a different sort of powerup. When we're creating the droppables in the drop method, we'll include the powerup as one of the parameters. I'll make it the third parameter before x and y. We'll therefore add it as the third parameter to the init method for each droppable type, and we'll pass it up to super in the subclass droppable types. Within the droppable superclass, we'll assign the parameter to a field, powerup. And now we can write the getPowerup method and simply return it. And when we run the game, it doesn't look any different, but we've put all of the structure in place so that each droppable can generate a different kind of powerup. On to step 3 now, giving the powerup some sort of power over the game. To do this, there will need to be hooks in the game that the powerups can connect to. So, for example, if I want the point doubler powerup to actually be able to double the points a player receives for each brick, somewhere in the code we need to double the points while the powerup is active. And we want to make sure we're building it in a way that makes room for other powerups we might add in the future that might also modify points. This is a design problem. We could go into Brick and write if double points powerup active, and later if turbo ball active, and later if paddle size multiplier active, and later if paddle skin active, and you get the idea. Eventually there would be dozens of checks all over the game. Instead, we're going to centralize all temporary effects into one object. I'm going to create a central effect manager class that the powerups and the parts of the game that are impacted by powerups can communicate with, a control hub for effects, so the code isn't a hodgepodge of different mechanisms for the different powerups. Right now, the only effect is a point multiplier. I'm going to handle this by creating a list of point multipliers. A powerup can add a multiplier, such as 2, to the list, and remove it once its time is up. Why a list instead of a single number? Because the player might catch 2 point doublers at once. If we only stored one multiplier value, we wouldn't know how many effects were active. A list lets each powerup add its own effect independently. So, in my effect manager init method, I'll create an empty list called points multipliers, and I'm going to write 2 methods, add points multiplier to add a multiplier to the list, and remove points multiplier to remove a multiplier from the list. You could also simply make this a public field and allow the powerups to add and remove their multipliers from the list directly. Those 2 methods, add points multiplier and remove points multiplier, are for the powerup. When it's active, it'll add its multiplier to the list. When its active period is complete, it will remove its multiplier from the list. Now we'll create a method for the bricks to use, getPointsMultiplier. The brick will multiply its points by this value and return that value from its getPoints method. When there's no powerup active, getPointsMultiplier will simply return 1. But if there's a multiplier powerup active, this method will return the multiplier value, increasing or decreasing the points gained. So up in Brick, we'll need to give the brick a reference to the Effect Manager object. I'm going to make it a field in case at some point a brick has more functionality and needs the Effect Manager object for something else. So I'm going to put it as an argument to the initializer and assign the reference to a field. And in getPoints, I'll simply return self.points times self.effectmanager.getPointsMultiplier. Down in the game, we'll create an Effect Manager object and pass it as an argument to each brick initializer. And now we need to connect it to the powerup. All kinds of powerups will go through the Effect Manager, so we're going to connect it in a general way to powerup. We'll make it a field, so we'll add it to init and assign it to a field. A subclass can invoke the superclass init and then send whatever message they need to send to Effect Manager to start their effect. But how do they stop it? We'll write a method called killEffect that is called from update when the effect's time is up. In powerup, it won't do anything. The base powerup class is now more of a template. Specific powerups will inherit from it and customize the behavior. If you're interested in the object-oriented terminology, powerup is an abstract superclass, one that is not meant to be instantiated. But we will make powerup subclasses, and each will write killEffect to do whatever they need to do when their time is up. So let's create a specialized powerup. We'll call it Points Multiplier. In init, after calling the superclass init, we'll send the add points multiplier message to the effect manager with a value of 2. And then we'll write kill effect and call remove points multiplier with a value of 2. That will be called in update when the power-up's time is up. In our power-up factory, we'll want to change the callable of point doubler to points multiplier. And we'll need to pass in the effect manager, which means we'll need to add it to the initializer for power-up factory and make it a field here as well. Okay, this step was a lot. Let's quickly review. We created a class to manage power-up effects called Effect Manager, and there is one Effect Manager in the game. A power-up will send appropriate messages to the Effect Manager to add an effect when the power-up is created, and remove an effect when its time is up. Other parts of the game that might be impacted by the Effect Manager will send it messages as needed so they behave appropriately if a power-up is in effect. Right now, our only effect is a double point effect when a brick is smashed. I think it will be hard to see this effect by watching the scoreboard, so I'm going to print points when bricks are smashed. Remember that lower bricks are worth fewer points. Let's run the game and keep an eye on the scores being printed. We can see that if I manage to get 2 power-ups, my points are quadrupled because they're in effect at the same time. Only 1 and they're doubled, and when the power-up is over, points go back to normal. Let's add another power-up for a quick review of the process. Let's speed the ball up. So I'll be adding 2 dictionary entries, one in droppable factory and one in power-up factory. I'll call it turbo ball. And then we create a subclass of power-up called turbo ball and have it communicate with the effect manager in its init method and kill effect. It will communicate through effect manager methods, so we'll add ball speed multiplier and remove ball speed multiplier to effect manager. The ball will also need a way to check the current speed multiplier during update, so we'll add a get ball speed multiplier method to effect manager and give the ball a reference to the effect manager object. And if we run that and manage to catch a gem power-up, we can see that it increases the speed of the ball. So finally, our game has power-ups. In the next video, we'll focus less on design and return to some Pygame features we haven't talked about yet. For now, if you want to practice with this, hook up a couple of other droppables to game effects. For example, you could increase the size of the paddle, increase the paddle speed, or change the color of the paddle. If you get stuck or want to share your successes, drop a comment below. And as always, have fun and keep coding.
Ah!